Alright, so now we're going to get into some reaction types. There's three main reaction types you need to know. The first one of these is going to be neutralization reactions. Neutralization reactions is where you have an acid. That reacts with a base that forms water and salt. And the salt is an ionic compound. Okay? So our main example is HCl, which is our acid, plus a base, NaOH, forms water and literally table salt, NaCl. The H and the OH make H2O. The Na and the Cl make our salt. So let's do this one. H2SO4 plus KOH. We know we're going to make water. H2O because we have an acid and a base. So the H and the OH react to make the water. So then we're going to go to the salt. Remember to always do the cation first. It's the cation of the second, which is going to be potassium, reacts with the SO4 from the sulfate. And do not forget to crisscross your charges. That should be a plus sign, not an arrow. My apologies. So sulfuric acid plus potassium hydroxide will yield water and potassium sulfate. The next one, nitric acid plus aluminum hydroxide. We know it's an acid and a base, so we know we're going to yield water, which means this H and this OH have reacted. So then we're going to plus the metal from the second one, which is aluminum, and the anion from the acid, NO3. Crisscross your charges, you'll get AlNO3, 3. So that's neutralization reaction. This is what I needed you to know. If you know this, I trust that you know how to make formulas by this point. The next one is a precipitation reaction, and this is where we form a solid, which will be insoluble product. You'll see these in lab a lot where we mix two liquids together and something normally white powdery is floating around the bottom of it. So you always got to check your reactions. And so you see you have cobalt chloride and sodium carbonate. You don't see any acids or bases there. So we go to the product side. It's cobalt 2 carbonate is actually what that would be. Let's check and see if it's soluble. Remember, we'll look at the anion, the carbonate, CO3, which is right here. And those are generally insoluble unless it's with an ammonium or a group 1 metal. Cobalt is not a group 1 metal, so this is insoluble, which means cobalt chloride would be our precipitate. Whereas NaCl, you have your chlorine right here, and chlorines tend to be soluble unless it's with a silver, lead, or mercury. So this one is soluble. We just call it soluble. Next one, lead-2 nitrate reacts with sodium iodide to form lead-2 iodide. So let's check that one first. I'll do this one in green. Iodines tend to be soluble unless they're with silver, lead, or mercury. So that one is insoluble, which means that one is a precipitate. Whereas NaNO3, nitrates are soluble with no exceptions. So that one is always soluble. The next one is oxidation, and then you have oxidation reduction. These are actually two half reactions that eventually will become a whole nother reaction. So an example would be, let's take a calcium, and let's say a neutral calcium that's going to turn into a positively charged calcium, or ion, which means it lost 2 electrons. A reduction would be just the opposite. Let's take a chlorine. Let's add 2 electrons to it. And now we get 2 chlorine ions. So what you're going to need to see here is this little mnemonic. I'll write it right here. Oil rig. Make sure you write this down, because this keeps you straight. Oxidation is loss, and when we talk about loss, we're talking about loss of electrons. Reduction is gain of electrons. So let's think about it. What things tend to oxidize, metals or nonmetals? Well, if we're losing electrons, I'll separate this down the middle now. We form positive, that's FOM. We form positive charges, which means metals tend to oxidize. Remember rust. Your bicycle when you were young used to rust. It was made of metal, and rust is a form of oxidation. Reduction would be gaining electrons, which means forming those negative charges, which means nonmetals tend to reduce. So keep that in mind, copy that down. There should be a spot in your notes for it. I think I put it in there. So let's go over to the right, on the very top, where it says lithium. So we have lithium that turns into lithium with a +1 charge. We see a positive charge form. You should know that that's oxidation. And we have a loss of electrons because it's in the product, which means lithium was oxidized. Br2, it added 2 electrons, so it gained 2 electrons. It also formed that negative charge. So bromine here was reduced. So now we can put these in 2 places at once. Now when you're doing these, you've got to go back and make sure you know the charges of everything that's going on. So I'm just going to go straight to the practice. We have H2 plus Cl2. Neither of those have charges because they're by themselves. So hydrogen has a charge of 0, chlorine has a charge of 0. But now I've formed hydrochloric acid, which is an ionic bond. If it's ionic, they now have charges. So hydrogen is +1, chlorine is -1. So what that means, this hydrogen became positive, which means it lost an electron, was oxidized, whereas the chlorine gained an electron, became negative, so it was reduced. And the one below it, you started with sodium, went to bromide. Sodium by itself, there's no charge there, so there's 0 charge. Bromine by itself has 0 charge. Then you see NABr, ionic bond, they have charges. Sodium is group 1, so it's +1. Bromine in group 17, so it's -1. So sodium, which is a metal, was oxidized. Bromine, your nonmetal, was reduced. So you see, because of our conservation of mass, oxidation and reduction occur simultaneously, which means at the same time. You can't have one without the other, otherwise you've created charge or you've lost random electrons. You just can't do that. So they're always going to occur simultaneously at the same time. The ones we did up top, those were half reactions. We normally don't do those by themselves, but you will see them on tests and quizzes and assignments because that's what's actually happening down the bottom ones. But the bottom ones are the main ones that you need to be able to recognize. And the way you tell these different, remember the neutralization had the acid and the base as the reactants. Then, when you went to precipitation reactions, you have to check all your reactants and or all your products, to make sure they're not all soluble. If all your products are soluble, then it's definitely oxidation reduction. So there's your tree chart, if you want that. That's all we got. Next up, read the math.